All right, thank you everyone. I'm very excited to be here at this conference. I'll tell you a little bit about myself and this open source project, Tethys Platform. So I received my PhD from Brigham Young University, which is about an hour south of here. So you're kind of in my backyard a little bit. And I currently work for a company called Aquaveo. We develop water modeling interface, I guess, software to help engineers develop water models. Think rivers, watersheds, things like that. But I'm also the creator of this project, Tethys Platform, and I'm really coming to you in my capacity as both the chair of the Tethys Platform Steering Committee and the chair of the newly formed nonprofit Tethys Geoscience Foundation, which we formed last year. So I suspect, has anyone heard of Tethys Platform in this audience? I don't. Okay, one person, because I talked to you yesterday. Yeah. Yeah, this is I feel a little bit like a fish out of water, but after hearing the keynote today, I feel like Tethys is really in the position of bridging that gap between kind of your hard science and data and the people who need it to do their jobs and affect change, right? So I'll start with a high-level explanation. Tethys Platform is a scientific web application development framework. And these screenshots showcase a few applications that our users have developed. They're really GIS-based. Most of them have a map displaying some spatial data, and many of them also are showing time series data and things like that. Dashboards are pretty popular. I'll warn you up front, it's not a WYSIWYG, asterisk, more on that later. To date, you use Python primarily to develop and JavaScript. When I developed this in my days at BYU, our goal was to target kind of the earth scientists, or I guess water resources scientists for me, who had a little bit of scripting experience, much like what you do in Jupyter, although Jupyter didn't really exist at that time. And we knew Python was kind of this growing language, and it turned out to be a good bet among the research community. And then JavaScript is needed to do some of the more interactive stuff on the front end. Now, there are some recent developments where this is changing, and I'll highlight those later on. Tethys Platform is also a synthesizer of web-based geospatial technologies. So we, early on, did a survey of open source GIS. This was back in 2012, so it's a little dated. And we kind of picked a few things to package with Tethys Platform. We frequently use it with things like GeoServer and Threads, PostGIS, and we're using web clients like OpenLayers and Cesium. Now that said, we've tried to make sure we're compatible with the OGC standards, and so it works well with other servers and services that support those standards. So now some more details. That's kind of the high level. It's open source. You can find us on GitHub at Tethys Platform/Tethys, and it's released under the BSD 2-clause license. We have a modest but international reach in our user base. This primarily has to do with the collaborations that Brigham Young University has had in the years since Tethys Platform was developed. We've worked with organizations like NASA Surveyor, the World Bank, and some others that have, I guess, helped us promote Tethys abroad. It's fairly easy to get started, especially if you're in the Conda ecosystem already. You can create a new environment with Tethys Platform, activate it, and then you run our Tethys Quick Start command that's installed with it. And that will get you up and running for development. Note on that, we are working In fact, I'm actively reviewing the pull request for our pip install. It's kind of funny how things come full circle. It initially was released and packaged on PyPI, and then Conda got big, and we're like, oh, let's do Conda. Now we're going to do both. So there's kind of three main pieces of Tethys. One is the portal. The Tethys portal is a website that you deploy on your own server, and it hosts your applications that you develop with Tethys. It's built on Django, and it's really intended to be this one-stop shop for all of your applications, and you can install applications that others have developed as well. This is a screenshot of one of our power users, GeoGlows, and all of the apps that they've developed. Since it's built on Django, it comes with a lot of the features you'd expect in a portal, like user management and site administration, and to some extent content management. The portal can be customized to match your organization's branding, so that you can kind of integrate it seamlessly with your web presence already. And then we rely on Django for the security features. Really, all of our core web functionality is coming up from our foundation of Django. The next component of Tethys is what we call the Tethys apps. These are actually kind of standalone Python projects. You create them by running the Tethys scaffold command, and then you can install them into your portal, and you will have an application up and running that looks kind of like this, really boring. But then we have kind of curated components, like we call them gizmos, that you can add to your applications. So for the maps and the plots and controls that your users need to interact. So OpenLayers and Cesium are the ones that kind of come out of the box. Many of our users also bring in things like Leaflet or other. It's not hard to bring in other libraries. Yeah. We also provide a number of plotting libraries. My favorite is Plotly, but we also have, I believe, Matplotlib and Bokeh built in. And then, like I said, we kind of provide these in gizmos, which you can think of as like widgets that you can insert into your application wherever you need them. And then more recently, we have what we call layouts. This is showing our map layout that's more of a full view. This kind of addresses a common use case that many of our users have of just wanting a map to show some data, be able to select features, see properties, and maybe plot some time series information associated with it. So it's kind of a simple GIS view. And then all of this is coordinated with our Tethys SDK with a number of APIs like the gizmos and the layouts, but also APIs for working with files on disk or working with our other software like GeoServer or other things like that. And then finally, the software stack, which really isn't ours. We don't develop threads or GeoServer or anything on here that you see. We really just kind of bring it together and package it. One of my advisors, Dr. Dan Ames, like to call it the big box of GIS stuff. And the idea is we wanted to just eliminate that initial really heavy burden of sorting through all the different things that are out there and just get users started on building their apps for their purposes to showcase their research. And kind of along those lines, we also include a few other things to facilitate cloud computing. The applications that I develop at Aquaveo often deal with a water model of some sort, and we have to change some parameters, run it, view the results. And so we use things like HDCondor and Task to accomplish that. So I'll show you just a few example applications that our community has developed. So GeoGlows developed a global streamflow service that is freely available through kind of a RESTful API. And along with it, they developed this application called the GeoGlows Hydro Viewer that allows users to pan around the globe, find a river that they're interested in, and see the 15-day forecast for that reach. like I said, this data set is global. It's built on top of ECMWF, one of their global models. Another one of our power users is this group in ECMod that was introduced to Tethys through NASA Surveyor. And this is just one of the apps that they developed. They've developed, I don't know, a lot. They're very prolific. But this one, they like to go with the dashboard type applications, and this one was for looking at drought monitoring. And ECMod is located in Nepal, and their purview is southern Asia. One of our users is in Western Africa and developed this fanfare portal that displays the results from a flood model that they run and makes it accessible to any of their constituent countries that need that information. And then this is one of our users from South Africa who developed this water energy food nexus application. And a lot of these applications, you'll notice, have kind of this theme of water resources, but really there's nothing in Tethys Platform that is water specific. We kind of provide the visualization tools, and you bring your data, right? This is an application that we developed on a contract with ASU and SRP for a hydrologic model called T-RIBS. And this one, we kind of pioneered a few new things. We obviously have the cesium 3D globe view, but we're showing some of the meshed input data of the model and trying to visualize that in a 3D environment. And then another that we've worked on for a project called FIRO in California. It's an Army Corps initiative called Flood Informed Reservoir Operations, is this application called Tethys Dash. And this one is another one that is kind of cutting edge. It's different than many of our applications because this dashboard is laid out interactively. So you can create these cells, you can drag them to the size that you want, drag them around, place them where you need them, and then you can edit and insert whatever visualization you want in it. And we're doing this for, I guess, reservoir operations right now as part of FIRO. And so we kind of worked with one of the reservoir operators and figured out what he looked at every day as part of his job. And really what it was is a list of bookmarks in Chrome. And so we took those and we generated visualizations in this Tethys Dash, and now he can lay them out and basically view them all at a glance. It's got some dynamic features where you can have, I'm not showing it here, you could have like a map with points on it, and when you select the points, other cells would update based on your selection, things like that. Or it can automatically refresh on an interval if you're kind of having this in an operations center, for example. We're hoping to incorporate this kind of approach for layout in our future Tethys development generally, to where the layout operations is done graphically, and then there's maybe a little programming to create these visualizations. One thing I failed to mention on this is that it uses a plugin architecture for the visualizations. So you can develop plugins for it. I believe it's using Intake as the interface, and connect it with whatever data and generate whatever visualization you need. And then another one that I didn't have a screenshot for because it's bleeding edge is we have someone in our community who's working on a React Pi Tethys scaffold, app scaffold. And this really, we're hoping will get us to where we envisioned originally of being able to do everything in Python. You can create really quite interactive applications while only using Python and no JavaScript required. And he's got it to the point where he can actually pull up a in-browser code editor, edit it, see updates in real time, kind of like Jupyter. So there are some, I guess we're we were born in kind of the 2010s era, and we need to update to the latest technologies. A lot has changed since then. So now toward cloud-native geospatial. This is kind of my first introduction to this group, coming to this conference, and it's been a whirlwind. I've learned a lot of great things. So how can we make Tethys applications more cloud-native? Well, we're already doing a few things, and I guess to understand what we're doing right now, you have to understand that a lot of it is being driven by the commercial development that we're doing at Aquaveo. So we have 2 commercial applications that we develop with Tethys Platform, City Water and Agua, and we're basically reaching the limits pretty quickly of how far kind of a Tethys thing out of the box can scale. And so in reaction to that, we've been working on a way to deploy the applications with Kubernetes, and kind of fine-tuning that for a few years now. It's quite complex, and what we have yet to do is to kind of simplify it and get it back to the community. That's on our roadmap. We've also been working with GeoServer Cloud folks who actually have a talk in the next block, where they've actually decomposed GeoServer, which is a fairly monolithic application, into microservices, so that you can actually deploy it in a Kubernetes environment and have it automatically scale up as on demand. And again, this is kind of really bleeding edge, so we've been working closely with those folks to implement it. But there's a lot of real good promise there. And then our project with ASU, the TRIBS model, is typically run on supercomputers, and we needed to execute this in a cloud environment. And so we found this paper by Igor and these people, I can't pronounce their names, I apologize, about using HG Condor, which is kind of a job scheduling system with Kubernetes, and combine that with HG Condor's MPI universe that allows you to run MPI jobs across a distributed kind of cloud environment. And we've come up with kind of a really preliminary draft of scalable computation. And again, this is early stages, but the hope is that eventually this will make it back to the community. And then, of course, from what I've learned, even in just one day, there are a lot of new technologies that we need to do. We need to add support for Stack API and COGS and T-Tiler and PyGeo API and many more. If there's something you think we should support, please come up and enlighten me. I'm here to learn and see what we can do to support this community in Tethys Platform. So I'll just give a few acknowledgments. Tethys Platform has been funded on not 1 but 2 NSF grants. The original grant during my PhD was an EPSCoR grant called CI Water, and funded the original development of Tethys Platform. More recently, we were awarded an NSF POSE, Pathways to Enable Open Source Ecosystems grant, that's really helping us build our community rather than the software, so that they can build the software, right? And that's really what spawned our nonprofit, the Tethys Geoscience Foundation, which I mentioned here. Our mission is to really enhance the impact of geoscience for the betterment of society and the planet, and we support development of innovative tools that lead to good outcomes, basically, is the summary of that. And then I have to acknowledge my employer for really taking up the mantle of Tethys in the interim between the 2 grants and keeping this project alive. And then I'd be remiss if I didn't mention we have a conference in Florida. So if you want to really learn more and get hands-on with Tethys, we encourage you to come out to kind of our inaugural conference called Tethys Summit. There are travel grants available. Just visit our website, tethysgeoscience.org. Thank you very much.